Welcome back to Module 5 of Week 5 of our course in Graduate Statistics, University of Cincinnati. Let's wrap this up. So we finished the previous video demonstrating to you what a two-tail-like test would look like, because we were calculating the probability that we would see extreme values in both directions, right? Both values above 0.30 or above 30%, indicating male discrimination, and values less than negative 30, indicating female discrimination. So both tails, the probability of getting numbers in both of these tails were being computed. And just by judging based on the height of these bars, we can already imagine that these probabilities are tiny. All right, now we want to know, we have reason to believe that if discrimination is there, it is really only to one side, right? There is no indication in history that males have been discriminated against. So there's no reason to believe that extreme values on this direction would happen. So we're more focused on trying to see the probability of getting negative 0.30 or less than that, just the bar on this side. So I asked you on the previous video, we created a variable called greater than absolute 30. We created that variable inside the dataset class simulation. And that variable had the value true when promotion difference was either greater than 30, one side, one of the tails, or less than negative 30, the other side of the tail. But now we want to create a different variable, just the variable smaller than negative 30, because that's the indication of female discrimination against females, because we computed proportion of female minus proportion of males that were promoted. So if males are more, that difference will be negative. So that value will have to be true when promotion difference is less than negative 30. And then we will, so first we'll create this variable. You can just click here once you're done. But I want to run just this selected line. Look at our data set. Now we created this new variable, and we need to compute the mean of this new variable that is inside the same data set. So let's see. So you see that the probability is still super duper tiny, right? The probability of seeing, it's much smaller than 5%, right? So it's actually 0.3%. So really, really unlikely to see something, a difference this large in the direction of female bias for in a completely random scenario. So again, which inferential statement is supported by the probability? Well, that there is evidence that females are discriminated against. Not that there is gender or sex discrimination, but that females specifically are discriminated against in promotion decisions, because the probability of finding that males are promoted more frequently than females, with a difference of at least 30% or higher, is very small under random conditions. Smaller than the typically accepted threshold. So this is smaller than this. Very unlikely to see that difference under random conditions. So choose up and let you be done with this week's stats. We started out with a question. Are managers gender biased when making promotion decisions? So we started with descriptive statistics. So let's get the contingency table here. We started with this descriptive statistics of the real data from the experiment. And we found that 21 out of 24 males were promoted in that weird situation where All managers received the same file, but the managers that were randomly assigned a male file went for promotion 21 out of 24. 21 times, right? 21 of them, 21 of the 24 decided for promotion, and then only 14 of the managers who were assigned a file, same file, but with the assigned sex of the applicant female, only 14 out of the 24 decided for promotion. So data suggests that managers who got the file marked as male decided for promotion more frequently, 88%, than managers that received a file marked as female, only 58%, a difference of 30%. The simulation of our random experiment indicated that the probability of finding a 30% difference in promotion decisions in the absence of gender bias under chance alone would be very small, p equals 0.003. Thus, we conclude that data does not support the hypothesis that there is no relationship between gender of the applicant, or I should say assigned sex. I don't think at that time people differentiated between these two, but I'm not sure, to be honest. But the assigned sex of the applicant in promotion decisions. Instead, it provides evidence of bias against females in promotion decisions. Unfortunately, this is a problem that is getting better, but is far from fixed. So you can see, this is data on bankers in 1976. Here's evidence of what's going on now. Even though things are better, there's still a clear bias in promotion decisions. There's a promotion gap, and there is evidence for that gap, which is reducing, but it's still there, so there's work to do. Also, if you're interested in this topic, check out an interview discussing recent data on gender bias in academia, so that we can be aware that this is out there and that there is work to do. Now you know you can indeed use data to make inferences about gender bias, which generalizes, of course, to other types of discrimination, and there is a systematic way for us to document those biases and also other issues that we can then address in our organizations, in our communities. So it's not just describing, it's identifying systems and processes that allows us to say with a level of with greater certainty that the differences that I'm seeing, the pattern that I'm seeing in my data, which is just a sample, actually can be generalized to the real world. All right. So nice to be here talking to you about inference, statistical inference. It's a very challenging topic to understand. This is one way of looking at it, but you will see that we'll come back to this, to these concepts recurrently, so that you can grasp it until the end of the course. All right. You see that the process is not very different across the various tests. All right. So I will hopefully see you Wednesday. Bye-bye.